Let me give you another example about the way that MIPS architecture stores data in the memory. Consider this question given the following contents of memory, where each square represents only one byte in memory. Show the values of registered $90 through $94 in hexadecimal after executing each of the following MIPS assembly language instructions. The Little Endian byte ordering should be used. Assume that the $S0 is initialized with this address 10,120 in the hexadecimal format, and this is the content of the memory with this address. The first point if in the hexadecimal 2010 C005F94 in the hexadecimal format. Now in the first instruction, we have a loaded word from this utterance. We will read 1 byte and store it in the $sign T0. Let me write it here. So the start address will be computed by adding the content of the $sign as 0 by offset 0. So since this register is the content of this register is this number. So adding 0 with this number would be here. So we want to write one word from this location. So since we used Little Endian, therefore, this is the rightmost byte and this is the leftmost byte. Let me write it here. It's $4 and 0 will be 0x. Steve 0. 10.35. There. I like that is stored in the first location of the memory and 0 is stored in the last location of this word or for bytes memory. In the next construction, we want to load half-fourth from this address and store it in the PT1. So let's first find the memorial address S0 plus 2. So 0 is this address plus 2 means here. So 1 by 1. 2 bytes of the memory or 1/2 worth will be read from this location and stored in the PT1. But PT1 can store data with size 6032 bits. Therefore, we need to extend the data. As you can see, we have two different load of work instructions. Load off for the signed data and load how for unsigned data in the unsigned data. In order to extend the data into 32 bits, we will put some zeros in the left side, but in the fourth, we should use the sign extension method. If the number is positive, you will put 0 in the left side. If the number is negative, you will put 1 or half F in the hexadecimal. So let's see here. What we have in this address is 0 plus to this number. The number is 010. Let me write it here. The number or how for that we want to read is C010. The PC010, but I should extend it into 32 bits. If you convert this number into the binary, you will see that this is a negative number, the sign, which is 1. So in order to extend it, I should put 16 in the left side or FFFF in the hexadecimal. So this is the data that will be stored in the TX1 register after performing load HA4 from this atlas. But in the next one, we have Lord of War on. So this time, in order to extend it into 32 bits, you will put 0. We don't care about the sign bit because the number is unsigned data and there isn't any sign of it. Let's find it. S0 plus 4. This is the start address. This is the low byte and this is the high byte. 5FB0. So 0x. 5F. Easier. You can see I put 16 zeros in the left side of this number to extend it into 32 bits because the number is unsigned. Again here we have load bytes and load bytes unsigned for the load byte. When you read 1 byte of the data, in order to extend it into 4 bytes or 32 bits, you should check the sign bit. If it is 00 in the left side, if it is 1, put 1 in the left side. But for the unsigned data, we don't care about the sign bit and we always put the zeros in the left side. Let's check it. Load byte, it's 0 plus 5. This is the data 1 byte and this is a positive number. So when you want to extend it, you will put 0 in the left side because the number of sign is 0. Or the number is positive. So this is the data. 5. 32 beats notation. Oops. And here for the scientific poll, we will load the content of the sign as 0 plus 694. 94 is a negative number if you consider it as a sign value. But here we want to consider it as unsigned. So it will be extended by, again, putting some zeros in the left side. So the data will be 94 in the hexadecimal. So for the half-worth and by data we have two different instructions for the same values. We have load half-fourth and load byte for the unsigned value. We have load off for unsigned load byte, unsigned instructions. In the signed version, you should check the signed bit and use the sign extension method in order to extend your data from 1 byte to the 32 bits or from 1/2 into 1 word, but for the unsigned data, we always put in the left side of the data zeros in order to extend it to the target size, which is 32 bits.